Alright, second video on our chapter review for Chapter 3, Transformations. The notation here is a little strange. Little r is always going to stand for a reflection of some kind. And the subscript, okay, whatever we put here, it's going to be lower to the right. It's called a subscript. Whatever we put in there is going to decide if it's a point or a line reflection. Obviously, if we put something like this, let's say we put y-axis, well, that's a line. Or if we were to put the point -1, 3, so that's a reflection through the point. So it depends on what is in this subscript, whether it's a line or a point reflection. So that's what we got to consider. In A, it says reflect, and then M is a line. So we have to say, okay, reflect over line M. In the parentheses, it's what point are we reflecting? We are reflecting point A over line M, and then perpendicular, same distance. Okay, that's going to land on D. All right, now we're going to reflect over segment FC. Okay, so that's this segment right here. Let's get rid of the other stuff, right? So we're going to reflect over that segment FC, point A. And now, here's what's tricky. Remember to move perpendicular. A lot of students miss this, in the past because they try to stay along the line that A follows. Well, there isn't one. A has to follow perpendicular to that line. It's going to land on E. A little tricky there. So put a star next to that. Make sure you study that. That's coming up. All right, now we're going to line reflect over H. Okay, and it's going to be point B that we're after. So here's line H. Okay, and we're going to reflect point B. Now that's nice. This line looks like it's perpendicular, so it is going to land on an easy one, E. All right, reflect over line D. We don't know, but it's going to land on B. Reflect over line AD. We don't know, but it's going to land on B. It must have come from something F, right? Perpendicular. Think, we got a path perpendicular and the same distance away. To me, it looks like it's got to be F. All right, E says reflect point F through the intersection of lines M and N. Wow. Okay. So what is the intersection of lines M and line M? Here's line N, here's line M. They hit right there. Basically, they're telling us to reflect what? Through a point. All right, so that's very tricky. Now we gotta reflect point F through that point. Now think midpoint. That's the midpoint. Oops, wrong idea there. Sorry. So when we reflect through a point, it goes straight through the point to the other side, same distance away. So that's basically all we're doing there. So that's point C. Okay? Translate segment FE vertically so that it maps onto something of itself. So look at this. The only thing it can... Okay, so translate. You know what's going to happen? It's got to keep the same slope. The only one that's going to do that is BC. Okay? So it's going to be segment BC. How many degrees does a hexagon have to turn to map onto itself? That goes back to our symmetry. So this one's, G's talking about rotational symmetry. Okay? So let's say it should say a regular hexagon, technically. All right? A regular hexagon has 6 equally spaced dots. Now I'm going to be off a little bit, I'm sure, but so that's a regular hexagon. Okay? And basically to go around a circle, it's 360 degrees. If you have 6 equally spaced dots, they're going to be 60 each. Now, of course, 60, 120, 180, 240, those are all rotational symmetry numbers, but 60 is the least. How many degrees does a hexagon have to turn, okay, to map D onto B? To me, it looks like there's one 60-degree turn there, right? And then there's another, oh, that's backwards. Uh-oh. Okay. So I think I missed this the first time I did it. Technically, what direction do we have to go? We got to follow in this direction counterclockwise. So technically, there's 1, 2, 3, 4. 4 of those 60s. So that's 240 technically. Or, so say 240 or negative 120. All right, if we're going in the direction we should. So be real careful of that. So next one, looks like, okay, so basically sequence. When they say the word sequence, what they're going to do is you're going to move the pre-image to a new location somehow, right? Whatever they tell us to do. Then from that new image, we're going to move for the second or third or fourth or whatnot. So sequence implies that we're going to take the pre-image, move to a new position, take another move from there, move to another position. And that's what's happening here. This is the notation for translate. Translate is in the form x comma y. The x move and then the y move. All right, so this is basically in the x direction, -3. So that says move left 3 and up 5. So 1, 2, 3, 1, 2, 3, 4, 5. C prime is going to end up right there. A, 1, 2, 3, 1, 2, 3, 4, 5. And B, 1, 2, 3, 1, 2, 3, 4, 5. There's B prime. Okay. Sorry, I should have a straight edge. I don't on this tool. Now, we took care of that one. Now we have to translate right 4, 2, 3, 4, up 3. A double prime is going to land there. 1, 2, 3, 4, 1, 2, 3. There's C double prime. 3, 4, 1, 2, 3. Okay, there's B double prime. Does it ask to state the coordinates? Yes. Okay, that's important. Oh, they did it down here. Good, good, good. Looks like 3, 4. B prime 2, -2. We can check this mathematically, of course. And, you know, what I mean is we could subtract 3 from the x's and add 5 to the y's. So, yep, 0, 1 looks good there. Take away 3, add 5, 3, 4, yep. Okay, it looks good. And now we can add 4 to the x, add 3 to the y. From here, watch how that happens. So we could just say 7, 7 without even looking because I'm using the math here. Add 4, add 3. Add 4, add 3. So that's what should have happened if I graphed it right. Okay, we'll write the single rule. Let's remember we went left 3, then up 5. Okay, then right 4. What else was it? Up 3. That makes, okay. So a single translation that we could have used would have been right 1, up 8. Okay, could have been that way. Here's a rule for it in case they want the rule. They say rule, this is technically what I mean when I say write the rule. That's what I usually use, but I think either one would be okay. All right, so next one is, okay, this is the first one they want us to do. It's not composition. Okay, your teacher might have mentioned composition. Might not have because we stopped doing it. Reflect over the x-axis first. So take C 1, 2, 3, 1, 2, 3. Okay, there's C prime. That's going to be 8. All right, that looks like A prime. Just checking something quick. Yeah, that looks good. 4, -7, perfect. So that's B prime. All right. Orientation switched, right? So the order of the letters is clockwise there, counterclockwise now. That makes sense in a line reflection. Now from here, we're going to rotate 90 degrees centered at the origin. Now let's try to remember what I did in the other problem. To get from the origin to C is a right 1, down 3. Your rise is 3, your run's 1. We'll switch that. Run 3, rise 1. Okay. And does that take us in a 90 degrees? Yeah, that moves us up 1 quadrant. So that is where C double prime should land. That looks like 4, no, Looks like 3-1 to me. Let's keep track of this. This was 1, -3. Okay, now let's go to B. This is going to be a little more work here. 1, 2, 3, 4, 5, 6, 7. Our rise is 7. Our run is 1, 2, 3, 4. So let's reverse that. Let's run 1, 2, 3, 4, 5, 6, 7. Rise 1, 2, 3, 4. That's got to be where B double prime lands. All right, looks like 7, 4, right? It was at 4, -7. A, looks like 8, 1. Switch it to 8, 1. I hope you guys are getting the idea here. Okay, that's 1, -8. Right there, it switched to 8, 1. Okay, write the single rule. All right, tricky. It's got to be some kind of line reflection. It's the only thing I know to start out with. Why? Well, when we reflect it, it switched the orientation. Then if we proceed to rotate, it keeps that orientation. So overall, the orientation is still switched. It has to be a single line reflection. It looks like a good one here. Okay, I'm estimating it's the reflection of a line y equals x. That looks good. Yep. Okay, so that was luck. We have to reflect over the line y equals x. Again, if they want the rule, unfortunately, we've got to do it that way. That's how we write the rule for y equals x. I would say that's the answer they wanted, though. Okay, that's it for this session. I will do another one for the next problems. Thanks so much.